Good afternoon, everyone. My name is Eero Hietanen, and as he said, my topic is development of QGIS-based topographic data management system. That's something we are doing in National Land Survey of Finland. First, I will tell you something about our business domain and the goals of the development. Then let's take a look for the requirements and some solutions we have provided. In the end, I will tell you about our open source contributions. There are two main processes to maintain topographic data. Periodical updating process and continuous updating process. There are about 120 operators editing the same dataset in these two processes. Periodical updating process is based on aerial photography of target area and the changes are detected with stereo mapping. Periodical updating process includes also some on-site inspections, which we call field mapping, and this periodical updating process is to be repeated for the same areas in intervals of 3 years, because our photo campaign covers almost the entire Finland in 3 years. Some of the essential themes of topographic database are updated in the continuous updating process, and in that process we use multiple data sources, get the data from municipalities, other governmental agencies, and we get also some feedback from customers and so on. It's also quite manual process, and it's not it's done like mostly annually for different areas or important areas. The main way to collect topographic data from aerial images is stereo mapping. The operator gets accurate representation of objects in 3D stereo view, and it allows more precise mapping than just 2D orthophotos, and those stereo desktops and stereo glasses are needed to do that work. One of the driver for our development is new national data models. The modeling work with stakeholders have started already since 2015, and the new data models are based on about 10 different data teams, including buildings and constructions, terrain, hydrography, traffic, networks, special and conservation areas, and administrative boundaries. Totally together there are over 100 separate feature layers with different topological relations. Here are some expected goals from the development. Product goals are enable the production of geospatial data based on new data modeling. Transition from producing map data to producing spatial data with more attribute data and so on. Enable versatile data quality management. Enable object-specific history and change management. Enable diverse data sources, automate processes, and adopt new technologies and standards. And as business goals, we expect high quality nationwide topographic data, more efficient and up-to-date maintenance, reduced application of data collection efforts, more compatible data with other registries, promote the use of datasets and enable adaptation to changing needs. Next, let's take a look for the requirements and solutions. In the beginning of the development, we had the current system as a reference. It's a small world-based, custom-made, full-featured topographic data management system with topological data model, which is quite different than the new one. There is built-in version and conflict management, and it's improved over a period of more than 20 years. And there are a lot of functionalities in it for different workflows. And we also had in the beginning the idea of the new technologies we are going to use, mainly PostgreSQL and QGIS, and we very early adapted on also some Java-based backend service. So we started with analyzing the current processes with users and process owners, and we end up this kind of set of separate requirements to be solved, that we can go in production and change to use this new system. First, we begin with the implementing concurrent data management. I have another slide for that. Efficient editing of topographic data is more iterative process, and it has needed a lot of iterative development and testing by our users that the tools are usable. Enabling stereo mapping is essential for us, and we have created an integration from our current stereo mapping software to QGIS. We have implemented the new national data models and also an ETL process from our current topographic database to the new system. Quality assurance and derivation of feature heights is something we are working on, and I have slides about those. We are also going to enable the processes of the various products. In the first phase, we are solving it that we are going to provide same kind of output than we have from the current system. So we will have another ETL process there, but it makes it possible that we will renovate our products separate a bit later. And management of categoric names, efficient use of the data sources is something we will need more tools still. And currently we are also planning how to implement or integrate the field mapping software to our system and processes. Solving concurrent data management was leading to this kind of architect solution, and it's called the core of the new topographic data management system, and it includes version control, history, and conflict management. There is a separate Java-based service to manage primary database and temporary work databases. And our operators use Job Manager plugin to control this Job Manager service and to create temporary work databases from certain areas. And then all the QGIS native tools can be used to manage the data in the work database. And after the work is done, user can register the changes to the primary database. And this Job Manager also includes conflict management if there are some conflicts between the changes of different people. Our quality assurance tools are very important for us, and we wanted to make the process and workflow more fluent for the users. This quality assurance tools focuses on logical consistency of the data. Other quality elements like coverage, completeness, up-to-dateness are evaluated in separate processes. And this quality assurance is based on rules. We have 3 different types of rules: geometry, attribute, and topological rules. And we aim for that the productional work is guided with the severity level of these errors. And currently we have 3 levels of errors: info, warning, and fatal. And why we did this custom implementation of the rules with database functions. QGIS provides some tools for quality checking, but custom solution provides comprehensive inspection for the data, both in work and primary databases. And we also have only one place to manage all the rules. And we think that we got the best performance with the database. There are hundreds of those rules. Also, advantages for the database solution is that it's not client dependent. So, for example, our ETL process from our current production system is using these same rules, but without QGIS. For the efficient editing of topographic data, we have done some improvements to QGIS tools. We have created a plugin to select active layer from map. It can be used both from QGIS and from the stereo mapping view. Then we have enabled editing mode and save for all layers. And we have created a topological segment reshape tool, which is quite handy tool, and it can also be used both in QGIS and from the stereo mapping view. We have also provided possible to visualize all the earlier changes that the user has done in the same work. We have things to do before productional use. For example, there are some custom ways of managing our road link data. Also, there are special needs for street address management, and there need to be some tools for efficient use of different imported data sets. About the derivation of feature heights, all the maintained topographic data should be in 2.5D, and we are using our national and 2000 height system. The management of the jet coordinates of the features are mostly automated, but there are also options to set height manually using stereo mapping, for example, for the certain cases. There are maybe difference for the up-to-dateness of our digital terrain model and aerial image and so on. There are also some specialties of the heights for the shoreline features and for the buildings, and it makes this implementation a bit more complex. So our current roadmap as a very simplified version. So in the phase 1, which has started from the beginning of 2021, we are aiming that we will replace the current system as the main tool to do the topographic data management, and we are estimating that we could get it in productional use in the early 2025. And it includes these tools for periodical and continuous topographic data production. It also includes field mapping and integration into our current product platforms. So new data and map products are scheduled in the next phase, and there are needed some production to be done with the new system, also to collect some of the new data content defined in the new models. And also we have on our roadmap new management and generalization process for map data, which is used as a base of our cartographic products. Okay, a few slides about open source contributions. There are open source guidelines in National Land Survey. They provide guidance whether the code should be released or not, and the main principle is that all the code should be open source, if not a specific reason. And these guidelines were published and adopted in 2022. And it has enabled for us the creation and adaptation of some best practices. We have developed some practices for development process for our continuous integration pipelines, and also we are working with our cooperation practices. The core is unfortunately not published yet. Our implementation began before we got these decisions of OS guidelines, and our core implementation has quite tight integration to our own infrastructure and our own data models. So it needs some work to open it. It's not scheduled on the roadmap yet, but I hope we will get it on the roadmap sooner or later. But here are some development tools we have contributed to. First, QGIS plugin development and packaging tools, and another one is PyTest plugin for testing QGIS Python plugins. Also, we have published or released some QGIS plugins: big layer, topological geometry shape tool, and a plugin for visualizing quality check results. We have also published database data quality checker, which is a service to execute quality rules for spatial objects in database and to produce a result in JSON. It works together with this plugin for visualizing quality checks. There have been some other related presentations. Yesterday there was Anteros and Olli's presentations, and also Tero had his presentation on Wednesday. There are links to these presentations also, and these slides can be found from the event schedule. So, thank you very much for the attention.